All right, let's jump right in today. We're going to be looking at how to up your coding game. Doesn't matter if you're just getting started or if you've been at it for years, we're going to be taking apart this article called 10 Common Coding Mistakes That Hinder Your Growth as a Programmer. You know, sometimes it's the little things we don't even realize that can trip us up.
Yeah, it's like these hidden gremlins that can really slow you down. What's really cool about this article is that it points out some of those subtle mistakes that can make a huge difference.
Exactly. And, one of those sneaky mistakes is jumping into coding before you've even thought about a plan. I've definitely been guilty of that. You get so excited to start building, you just want to dive right in.
Oh, yeah, I've been there. It feels like you're making progress, right? But it's kind of like building a house without a blueprint. You might end up with something that's, well, not so stable, hard to work with, maybe even have to tear it down and start over.
Oh, tell me about it. I once tried to build an entire e-commerce site without any real plan. Oh man, it was a disaster. My code was a tangled mess. Adding anything new was like impossible. So how do we avoid that? Like, what can we actually do to make sure we're planning things out properly?
Well, there are some pretty simple things that can help a lot. One is something called pseudocode.
Hmm.
It's basically like sketching out your code, but in plain English. So before you get bogged down in all the syntax and stuff.
So it's like making a rough draft before you write the actual code.
Yeah, exactly. It helps you organize your thoughts, make sure your code has a good structure right from the start.
Makes sense. So what else can we do?
Flowcharts are really helpful. They can visually map out how your program flows, like a map. You can see potential problems or bottlenecks even before you write a line of code.
Well, that's a great idea. It's much easier to change things on a flowchart than after you've written a ton of code.
Right. And another thing that helps is breaking down big problems into smaller chunks. It makes the whole planning process less scary.
Okay, so let's say we've got our blueprint all figured out. The next thing is, how do we make sure that other people, or even ourselves down the road, can understand what we've built? And that brings us to the next mistake. Ignoring code readability and documentation.
Oh, yeah, that's a big one. And, it's not just about being nice to other developers. Writing readable code is about making sure your code is maintainable, so you can change it easily later on.
And so you can actually figure out what you did a few months later. I know I've written code that I couldn't even understand a week
Oh,
later.
the future self problem, that's a classic. And that's where good documentation comes in. It's like leaving yourself little notes, breadcrumbs you can follow. It's about explaining what the code does and why it's there.
The article has a great example of this, comparing a function called, well, calc, which is just
Yeah.
terrible, with another one called calculate total cost. The difference is like night and day.
Oh, yeah, that's a good one. With calculate total cost, you can actually see what each part does, what the function is supposed to do. Calc is like a black box. Who knows what's going on in there?
Right. So, okay, documentation is super important. But what about the code itself? What can we do to make it more readable?
One simple thing is to use good names for your variables and functions. Like, instead of just using X or Y, use names that actually describe what the data is.
So it's like labeling the ingredients in a recipe.
Exactly. And comments, those little notes in your code, are super helpful for explaining things that aren't obvious. Like if you're using a complicated algorithm or making some assumptions about the data.
I know those comments have saved me so many times when I'm trying to fix a bug or figure out why something isn't working.
And you know what else makes a big difference? Formatting. Just making sure your code is indented properly and spaced out. It's like the difference between a clean desk and a messy one.
Oh yeah, a well-organized code base makes you happy just to look at it.
And speaking of keeping things organized, that reminds me of another important topic: error handling. We tend to focus on making our code work perfectly under ideal conditions. But what happens when things go wrong?
Oh, that's a great point. Neglecting error handling is like driving without a spare tire. You might get lucky for a while, but eventually you're going to get stuck.
It's like building a bridge without any safety rails. It might look okay, but what happens when someone trips?
Exactly. You need those safety nets in your code, so when things go wrong, it doesn't crash and burn.
This is not about preventing errors altogether. It's about how you handle them when they inevitably happen.
Right. Like imagine you're on a website and you type in the wrong password. A good error handling system will tell you, hey, wrong password, try again. But without it, you might get some weird error message or the whole site might freeze.
And that's super frustrating for users. So what are some practical ways to make sure we have good error handling? Well, one common thing is using try-catch blocks. It's like saying, okay, let's try this code, but if something goes wrong, here's what we'll do.
So you're planning for the unexpected.
Exactly. And it's also important to validate user input. Like, if you're asking for an email address, make sure it actually looks like an email address.
It's amazing how many websites just let you type anything in those fields. It's like they're asking for trouble.
Yeah, and then things break. The article shows how to improve error handling in a JavaScript function called divide numbers. They use a try-catch block and check for division by 0, which is a common mistake.
That's a great example. It shows how a little bit of error handling can make your code way more reliable. So we've talked about planning, readability, and error handling, all super important. But sometimes we just make things more complicated than they need to be, even when everything's working fine.
Oh, that's so true. Sometimes as programmers, we get carried away trying to be clever or using some fancy new technique. We forget that simple can be better.
It's like building a robot to make a cup of coffee when you can just, use a coffee maker.
Exactly. Remember the KISS principle. Keep it simple, stupid. It sounds a bit harsh, but it's a great reminder.
I love that. The article shows how a super complicated function called isEven can be simplified to just one line of code using the modulo operator.
Yeah, it's about stripping away all the unnecessary complexity and making the code elegant.
It's like decluttering your code. And speaking of decluttering, that brings us to another mistake, ignoring code reusability. It's like having to bake a cake from scratch every single time instead of using a mix.
Oh, yeah. Reusable code is like that cake mix. You can save so much time and effort. Why write the same code over and over?
I've definitely been guilty of that. Copying and pasting code from one part of my project to another seemed like a good idea at the time, but it makes it a nightmare to maintain later.
Right. And it actually goes against a key principle called DRY, don't repeat yourself. When you have the same code scattered all over the place, it becomes really hard to update and maintain.
And it makes your code base way bigger than it needs to be.
Exactly. With reusable code, you can create these building blocks that you can use in different parts of your project or even in future projects. It's about being efficient and organized.
So how do we get better at writing reusable code?
It's about thinking ahead a bit. Think about how this code might be used in other situations. Can you make it more generic, more flexible? The article gives an example using a circle class. They create a class with methods for calculating the area and the circumference instead of writing separate functions. Then you can create multiple circle objects and reuse those methods.
So it's like creating a template that you can use over and over again.
Exactly. It's a great way to make your code more organized and easier to maintain. And speaking of maintaining code, that brings us to another super important topic, version control. Ignoring version control is like walking a tightrope without a safety net. It's super risky, especially when you're working with a team.
I learned that the hard way, early in my career. Lost hours of work because I wasn't using version control. It was painful.
Oh, I can only imagine. Version control systems like Git are lifesavers. They let you track changes, go back to previous versions, and work together with others without messing things up.
It's like having an undo button for your entire project. What else is so great about using Git?
One of the coolest features is branching. You can create these separate versions of your code where you can experiment with new things or fix bugs without breaking the main version.
It's like having parallel universes for your code.
I love that analogy. And when you're ready to merge those changes back into the main version, Git has tools to make that super smooth.
And what about writing good commit messages? The article talks about that too.
Oh yeah, that's important. A good commit message is like a mini story about the changes you made. It explains what you did and why you did it.
They give a great example in the article. Feat. Add user authentication functionality. Implement login and registration forms. Create user model and database schema. Set up JWT for secure authentication. Add middleware for protected routes. Closes. #123.
That's perfect. It's clear, concise, and even references the issue that was fixed. Writing good commit messages takes a little practice, but it makes your project history much easier to understand.
All right, we've covered a lot of ground today, but there's still so much more to talk about.
We've only just scratched the surface. There are even more coding mistakes we need to uncover and figure out how to turn those mistakes into learning opportunities.
Definitely. We'll be back for part 2 of this deep dive, so stay tuned.
See you there.
All right, welcome back to the deep dive. Before we get back into it, I just want to say it's okay to make mistakes. It happens to everyone.
Oh, absolutely. That's how we learn.
Exactly. The important thing is to learn from those mistakes, right?
Yeah.
And use them to become better programmers. So where were we? Oh yeah, we were talking about how even with a solid plan, we can still end up with code that's hard to read and maintain.
Yeah, that's right. Code readability and documentation, right?
Exactly. You know that feeling when you go back to your own code and think, who wrote this? It's even worse when you have to try to understand someone else's code.
Yeah, that can be a real pain. And it connects back to all those principles we've been talking about, like planning and reusability. It's all about making code that's not just functional, but easy to understand and work with.
It's like building a house with clear labels on everything. Makes it so much easier to fix things later on.
That's a great way to put it. And, the person you're making it easier for might be your future self.
So true. So what are some tips for actually making our code more readable? I mean, how much documentation is enough?
Well, a good rule of thumb is to comment on anything that's not immediately obvious. Like if you're using a complex algorithm or making certain assumptions about the data.
So don't comment on every single line, but explain the tricky parts.
Yeah, exactly. Think of it as a conversation with someone who's reading your code for the first time. What do they need to know?
That's a great way to think about it. And what about naming things,
Yeah.
like variables and functions?
Oh, yeah, that's huge. Use descriptive names that explain what the variable or function does. Don't use abbreviations or single letters.
So instead of something like username, use username.
Much better. It's like using labels in a filing cabinet. Everything is much easier to find when it's clearly labeled.
Makes sense. And of course, there's formatting. Just making sure your code is indented correctly and spaced out makes a big difference.
It's like the difference between a well-organized library and a cluttered bookstore. A well-formatted code base is just more pleasant to work with.
Speaking of things that aren't pleasant, let's talk about errors. We talked earlier about how neglecting error handling is like driving without a spare tire.
Right, and it can lead to all sorts of problems, from annoying user experiences to, major system crashes.
It's like building a bridge without any safety railings. Someone's going to fall off eventually.
Exactly. Error handling is about building those safety rails into your code. So when things do go wrong, the whole thing doesn't collapse.
So how can we get better at anticipating those potential problems and, building those safeguards into our code?
Well, one thing is to research common errors for the specific language or framework you're using. There are often best practices for handling specific types of errors.
So don't reinvent the wheel. Learn from what others have already figured out.
Right. And another thing is to think about all the ways things could go wrong. Not just the happy path, but also those edge cases.
Like, what if the user enters the wrong data
Mm.
or the network connection drops?
Exactly. And when you're actually writing the error handling code, there's a principle called fail fast and fail loudly.
I like that. What does that mean?
It means you should try to catch errors as soon as possible. And when you do, make it obvious that something's wrong. Don't just let the program crash silently.
Give a clear error message that explains what happened.
Exactly. Make those errors visible and actionable.
Okay, so anticipate errors, handle them gracefully, got it. But sometimes we make things way more complicated than they need to be, even when everything's working fine.
Oh yeah, overcomplicating solutions. It's a classic programmer trap. We want to be clever, we want to use the latest cool stuff, but we forget that sometimes the simplest solution is best.
It's like using a supercomputer to do basic math.
That's a great analogy. Remember the KISS principle. Keep it simple, stupid.
I love that. I know I've been guilty of writing code that's so complex even I don't understand it later.
We've all been there. Sometimes we just need to take a step back and ask ourselves, is there a simpler way to do this?
And often there is. Like in that example from the article with the IEven function. They showed how to simplify it from this big, complicated mess to just one line of code.
It was beautiful.
Please.
It's about making your code elegant and efficient by stripping away all the unnecessary stuff.
It's like decluttering your code. And that reminds me of another important concept, code reusability. We talked about this a bit earlier.
Ah, yes, reusability. It's about writing code that can be used in multiple places, not just for one specific task. It's like having a set of Lego bricks that you can use to build all sorts of things.
Exactly. And it saves so much time and effort. It's also about following the DRY principle. Don't repeat yourself.
Right. When you duplicate code, you're just making things more complicated and harder to maintain. If you have to change something, you have to change it in multiple places, which is a recipe for disaster.
So how do we get better at writing reusable code?
It's about thinking ahead and considering how your code might be used in different contexts. Can you make it more generic, more flexible?
Like in that example from the article with the circle class. Instead of writing separate functions for calculating the area and circumference, they created a class with methods for both. Then you can create multiple circle objects and reuse those methods without writing the code again.
Exactly. It's a great example of object-oriented programming and how it can be used to make code more reusable.
It's like having a toolbox with all the right tools for the job.
And when you need to do something, you just grab the right tool from your toolbox instead of having to build a new one every time. So much more efficient. Okay, we've talked about planning, readability, error handling, and reusability. Now let's talk about something that's essential for anyone working on a team, or even just for managing your own projects over time. Version control.
Oh yeah, version control. It's like a safety net for your code.
Exactly. Ignoring version control is like walking a tightrope without a net. It's incredibly risky.
Tell me about it. I learned that the hard way early in my career. I lost hours of work because I wasn't using version control. It was not fun.
Oh, I can only imagine. That's why version control systems like Git are so valuable. They let you track changes, go back to previous versions, and work with others without messing things up.
It's like having an undo button for your entire project.
Exactly. And one of the coolest features of Git is branching. Branching lets you create separate versions of your code base where you can experiment with new features or fix bugs without affecting the main stable version.
It's like having parallel universes for your code.
I love that analogy. You can think of the main branch as the production-ready version of your code, and the branches are where you can work on new things or fix problems in isolation. And when you're ready to merge those changes back into the main branch, Git has tools to make that process smooth and painless.
That's amazing. And what about writing good commit messages? The article mentioned that too.
Yes, commit messages. They're like little time capsules that tell the story of your project.
So each commit message should be like a mini story about what you changed and why you changed it.
Exactly. And remember, someone else might need to read those commit messages someday. So make them clear and concise. The article gave a great example. Feat. Add user authentication functionality. Implement login and registration forms. Create user model and database schema. Set up JWT for secure authentication. Add middleware for protected routes. Closes, #123.
Perfect. It's short, sweet, and to the point. It tells you exactly what was done and why.
Exactly. Writing good commit messages takes a bit of practice, but it makes your project history so much easier to understand. Okay, we've covered a lot of ground today, but we're not done yet. There are still a few more coding mistakes we need to discuss.
We've still got more to uncover and explore, so stay tuned for part 3 of this deep dive. Welcome back. It's amazing how many things there are to think about when you're coding.
Yeah.
Like we've been talking about all these common mistakes, and it really makes you realize how much there is to learn.
It really does. And you know, a lot of these things, these mistakes, they kind of come from habits we pick up early on, right? We don't even realize how much they can affect us down the road.
Yeah, that's so true. We're so focused on getting things to work, we forget about the bigger picture. But here's the thing. Even if we avoid all these mistakes, how do we keep up with everything that's changing in tech? I mean, there's new stuff coming out all the time.
Yeah, it can feel like you're trying to drink from a fire hose sometimes. But instead of getting overwhelmed, I think it's helpful to see it as an opportunity. Like there's always something new to learn and explore.
Yeah, that's a good way to look at it. But how do you actually do it? How do you stay on top of all this new stuff?
Well, you don't have to learn everything, right? You can be selective, choose things that are relevant to your work or your interests. But the most important thing is to have a mindset of continuous learning.
The article talks about how continuous learning is like not even optional anymore. It's essential for staying relevant.
Yeah.
But how do you actually make time for it? We're all so busy.
Right. It's about finding ways to fit it into your routine, you know? Even if it's just 30 minutes a day to read an article or watch a tutorial.
Make it a habit. Don't wait for the perfect time because that might never happen.
Exactly. And there are so many resources out there, like online courses, blogs, podcasts, coding communities, local meetups.
Oh, and books. Don't forget about books.
Yeah, totally. And remember, learning doesn't have to be this solitary thing. Working on projects with others, doing coding challenges, that's a great way to learn too.
It is. You can learn so much from other people just by seeing how they do things. And you learn a lot when you get stuck and have to figure things out on your own too.
Definitely. Those moments when you finally figure something out, those are the best.
So true. Speaking of figuring things out, let's talk about testing. I used to hate writing tests. It felt like a chore. But now I realize how important it is.
Yeah, testing is like that safety check, right? It's like building a rocket but not checking if all the parts are working.
You might get lucky a few times, but...
Eventually something's gonna go wrong.
Exactly. Testing helps us make sure our code is reliable and stable. But I'll admit, I still sometimes struggle with writing tests. Where do you even start?
Have you heard of test-driven development? TDD?
Yeah, I've heard of it.
It's a really interesting approach. It's basically where you write the tests before you write the code.
So you're defining how you want the code to behave before you even write it.
Exactly. It seems a bit backwards, but it can really help you design better code that's easier to test.
Interesting. And when you're writing the tests, what should you keep in mind?
Well, try to think of all the different ways your code could be used, not just the obvious ones. The happy path and the edge cases. Make sure your code works correctly in all those situations.
So it's about being proactive,
Yeah.
anticipating problems before they happen.
Exactly. And make sure your tests are easy to understand. They're like documentation, too.
So other people can see how your code works and what you were thinking.
Right. And run your tests regularly, ideally every time you make a change to your code. That way you can catch any problems early on. We've talked about a lot of technical things today, but there's one more thing I think is super important for any programmer to develop: soft skills.
Yeah, soft skills are often overlooked, but they're just as crucial as technical skills.
If not more so. Being
Yeah.
able to communicate well, work effectively with others, all that stuff is so important in today's tech world.
It's funny. I used to think that all that mattered was writing amazing code. But as I've worked with more people and bigger teams, I've realized that soft skills are just as important, maybe even more.
Totally. It's like building a house. Knowing how to use the tools is important, but you also need to understand what the people living in the house actually need.
That's a great way to put it. You can build the most technically impressive thing in the world, but if it doesn't work for the people who are going to use it, it's not really a success.
Right. So things like communication, teamwork, empathy, those are all crucial skills for any programmer.
Yeah, and empathy is something that I think is really important. It's about understanding the impact of what we build and how it affects other people.
Totally. We're not just writing code for the sake of writing code. We're building things that people are going to use, and we need to be mindful of that. It's about making the world a better place through technology.
Absolutely. So as we wrap things up here, what's one thing you want our listeners to take away from this deep dive?
I think the biggest thing is that being a great programmer is about more than just technical skills. It's about continuous learning, adapting to new technologies, and always striving to improve, both technically and as a person.
I love that. It's about embracing the journey, the challenges, and the growth that comes with being a programmer. And it's about remembering that making mistakes is part of that journey. We all make mistakes, and that's okay. What matters is that we learn from them and keep moving forward.
Couldn't have said it better myself. So keep coding, keep learning, and keep pushing yourselves to be the best programmers you can be.
That's a wrap on this deep dive into common coding mistakes. Thanks for joining us. We hope you've enjoyed this episode of The Deep Dive.
See you next time.